Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And if you scroll down in the search question, search for path sum. So there is a question number 112 and it's come under the easy category. So we will try to solve this. Let's click on it. So let's read the question. Given the root of a binary tree, so one tree, so this is related to a tree. So the tree is given. We have the root is given. So if you see whatever the function name it is, the argument is root because it is given. And an integer target sum. So there is one more variable target sum that is also given. We need to return true or false if the tree, if this tree has a root to leaf. Root to leaf. So what is the leaf node? A leaf node is that node which has no children, which means there is no left child, there is no right child. That is called a leaf node. So from root to leaf, path such that adding up all the values along the path equal to the target sum. So basically, we have given some tree, we have given some target, right? So we need to find if we start from root and we will traverse till leaf, any leaf. Let's suppose if we start from 5, the leaf could be 7, the leaf could be 2, the leaf could be 13, and the leaf could be 1. So they said either like I don't care whether you travel from 5, 4, 11, 2, whether you travel 5, 4, 11, 7, whether you travel 5, 8, 13, or 5, 8, 4, 1. So these are the four like way path from root to leaf in this tree. But if whatever the path you choose, so let's suppose if I choose 5 8 4 1 or 5 8 13 or 5 4 11 6, whatever the path you are going to choose, if you sum all the values, whether all the sum equal to the target sum which I provided, if it is equal, then just return the true. If it is not equal, then return the false. Like any path. So let's suppose we have 5. So if we traverse 5, 4, 11, and 17, so and we say the target sum is 22, right? So if we add 5 plus 4 plus 11 plus 17, so it is not a 22. If we choose this path, 5 plus 4 plus 11 plus 2, so it could be 22. And so we are find one path, then we are going to return true. Let's suppose if we choose this path, 5, 8, and 13, it is not 22. Then 5, 8, 4, and 1, so it is also not 22. So we need to solve this question. So how we are going to solve this question? So it means we need to check each and every path. So let's go to this whiteboard. So this is a tree, the same tree which is given in the question. So first focus on the left hand side, only on the this side, only on this side. So we have some trees given, all right? And like just like forget about the coding, how we are going to approach the solutions first, because otherwise writing the code is like very easy. We can write for loop, if loop, any loop, but how to approach the solution? So we have to check each and every path. So how we are going to check each and every path? So one way is the recursive solution. The recursive solution is, if the person at standing at 5, if they said okay, I am 5, what is the remaining amount? 22 minus 5, so 17. What is the remaining amount? 17. So can you check in this tree, do you have the 17? Right? So this is the sub problem. If you have, just return me with true or false. It's the same thing, the root node tell to its right hand side as well. Can you check, do you have the 17 in total from root to left, root to leaf? If you have, return me. So basically what it said is, the root node said, 1 minute. Hmm. So this root node, 5 node said to left hand side, just calculate and give me true or false. So 5 said, okay, I know I am 5. The remaining sum is 17. So now this is a sub problem. So you can consider this a sub problem. So I am passing this sub problem in the same function, but the target sum is 17. Can you do this and can you calculate whether you have the sum 17 or not? Similarly, 5 said, okay, I am passing into the right hand side as well. and checking, do you have the some 17 or not? This left hand side will also give some value, this right hand side will also give some value, true or false. So whoever will give true, so the output will be true. But if both give false, the output will be false. So let's uh, consider one by one. So let's suppose uh, if 5 said to left hand side, can you solve the question for me, the recursive way. So the recursive means the function is calling itself. So there is a one function, the function name is has path sum, where the root is 5, target sum is 22, as an example. Now the 5 said to the left hand side, can you calculate the sum, can you calculate the sum? So this is a subtree. So 5 said, so if we have to write, so okay, let's see what's the constant. So one constant is the root can be, the number of nodes can be 0 as well. So let's try to put that constant. So if root is none, we need to return none. So this is one of the constant. Okay. So this 5 said to left hand side. So he said, okay, I will pass the whole tree, which I mark in red, into the same function. Right. So basically, so self dot, I will call the same function has path sum, and instead of root, I will pass root dot left, and instead of target. So when we are on the root, our target is 22, as an example 22. But now we are passing this tree. So what is the remaining sum? Because 5 is already we calculated. 22 minus 5, 17. So it means target sum minus root dot value. So whatever the target sum minus root dot value. So we are calling some function, so it is going to return some value, whether true or false. So has path sum on left side. So let's suppose it is calculating something. The same thing, the same thing, the 5 said to its right hand side, can you calculate and tell me whether will you give me true or false. So the same thing. So let's suppose this is the right hand side, and but in the root it will pass root dot right, and rest everything will be remain same. So this is going to calculate. So now, so let's figure on the only on the one side. So first, 5 will call to like this subtree, the red mark subtree, and the target sum is 17. Okay. Now we are on the 4. So here root is 4 and target sum is 17. Now it will come again. So now 4 said, okay, I know I am 4. So what is 17 minus 4? 13. So can you calculate in your left hand side, do you have the sum 13? Okay, so we are passing over. Can you calculate? So in the root node, but we have 11, and in the target sum, we have the 13. Okay, now 11 said, okay, I know I am 11. Can you calculate what is the the remaining sum? So what is the remaining sum left? So here 17, here 13. Now we have 11. So 13 minus 11, 2. So can you calculate? Do you have the 2? So it said, no, I don't have the 2. Right, so it's written false. Okay, now it's also said, okay, they said, okay, from left hand side I am getting false. Can you check on the right hand side as well? So I am checking on the right hand side as well. On the right hand side we need some 2, we get 2 here. Right, so they said, okay, I got true value. So it get 2 true, it also going to return true, it is also going to return true. So at the end we are getting the true. But there is a one more condition, it is given, it is mentioned, the we need the path should be from root to leaf. It could be the scenario like 5. Let's suppose if I give uh, let's suppose if there is a sum which is 20. All right, so 5 plus 4 9, 9 plus 11 20. If I said, can you check of is there is some 20 exist from root to leaf, then by this logic, by only checking this logic, 5 plus 4 plus 11, okay, this is returning true, it's returned true, but this is wrong. because 11 is not a leaf node. 11 is not a leaf node. So we need to put one more if condition. As soon as it is come, we need to check if whatever the node we reaches, if root dot left is none and root dot right is none, and so let's suppose we reaches 2, so we will check whether you are the leaf node or not. So we will check. So once we reaches 2, we are checking whether you are the leaf node or not. So we are checking uh, if root dot left is none and root dot right is none, and value. So and target sum. So what could be the target sum, because it is like a 2 is also going to call the same function again. So target sum equal to 0. If it is, then we need to return true, right? So now we got the value from left hand side, whether true or false. We got the value from the right hand side as well. All right. So we will just return. Let's suppose first give true or false. Second give also true or false. So we will just put the or operator, because if one is true, then we have to return true. So let's try to run it. So something is wrong. So let's see what is wrong. So we are getting false, and second case is fine, third case is fine. What's wrong? So if root is none, return none, which is fine. If root dot left is none and root dot right is none and target sum, and so we are getting the target sum. So first we are on the 5. 5 will call 4. So when we are at the 4, so target sum 22, then 22 minus 5, 17. Okay, 4. Just a second. There is something like some mistake occur. So it look like, so this is wrong, because we are checking, we are passing 2 here. So at the end we are passing 2 here. So we will check whether the target sum is equal to the root dot value, because we need 2, whether we find the 2 or not. So we will check here whether we find the 2 or not. So let's try to run it. So solution has been like sample test cases has been accepted. So let's try to submit it. So solution has been accepted. So this is like the recursive solution, which is very straightforward. So recursive is generally easy. Like what we have to do is we will just call the same function on the left hand side. We will call the same function on the right hand side, and we will say, okay, we are calling the same function on the left hand side. We are calling on the same function on the right hand side. Along with that, whatever the remaining sum, because 5 is there, whatever the remaining sum they left, we are passing that, because we need two variables. One is root, one is target. So root we already passed, target we need to pass, and whoever is going to return true or false, going to just like return that. Along with that, in the recursive solution we need base cases. So one base case is if root is none, then we need to return none. Along with that, the other base cases, because we need to check from the root to leaf, then we have to check whether the leaf, whether we reaches the leaf node or not. So if root dot left is none, root dot right is none. Along with that, whatever the sum we required, whether we uh, reaches that point or not. So whatever the sum is required, whether we reaches that point or not, then we are going to return true. So this is the recursive solution, but we can solve this using the iterative solution as well. So iterative solution is also very simple. So generally, if we have to convert a recursive solution, in most of the cases, if you have to convert recursive solution to the iterative solution, then think about it by using the extra space. Either it should be queue or either should be stack. So in this case, we will took a stack. All right. So we will took a stack. So let's try to implement the iterative solution. So as part of the iterative solution, so what we will do is we will take a one stack, right? We will, because we are on the root, because root is given, right? So we have to start from the first node itself, right? Either we traverse left hand side or either we traverse right hand side. So we have to but start from the root only. So and we need to use the stack. So when we use stack or queue, what we generally do, we whatever the first element it is there, we will insert into that stack. Then what next? Then we will run some while loop and we will check until the stack is empty, and we will start popping the node, and then we will start inserting the left node and the right node. The same thing which we will do in this uh, like uh, mm, logic itself. So first let's write the edge cases. If root is none, then return none, because it is mentioned in the question itself, like the constant, the root can be none, the number of nodes can be zero itself. So which is the one base case, or you can say one condition, because they can keep the zero as a root node. Okay, now we need to take the stack. So stack could be a list, right? So we need to take stack. So what we need to insert into the stack? So we need to insert into the stack. One is the root, right? So one is the root. So we need to insert root. Along with that, what we need to insert? We can insert the current sum. So what is the current sum? Current sum is the 5. So current sum could be 5. So if you see this diagram, so first we need to insert 5. So in the starting, we have only one stack or only empty list. So first in the list, we because we are on the root, so we are going to insert a root. So we inserted 5. Along with that, our target sum is 22, right? So what is the remaining sum left? So 22 minus 5, 17. So the same thing we need to insert. So root we already inserted. What is the remaining sum? Target sum minus root dot value, right? So we insert it. So generally, like the same approach, okay, forget this, whatever we have inserted. But what is the common approach? Common approach is, if we have to convert recursive solution to iterative solution, the common approach is like we either use stack or queue. Whatever the data structure we use, first we insert first element, then we will run some loop until the stack is not empty or until the queue is not empty. So while stack, right? Then what is the next step? Because there is a one element into the stack. So now we need to pop it. So we will pop this element. So if we pop this element, it will give two numbers. One is 5 and one is 17. So let's pop this element. So stack dot pop. So we are going to pop this element. It will give two numbers, because we are inserting two things. Uh, we are inserting two things. One is node, one is the sum. So it is going to return two things. One is the node, one is the current sum. So current sum is 17, or you can say the remaining sum. All right. So now once we get the node, what we have to do. So as soon as we get the current sum, we need to do check. We need to put some check, because otherwise we will do some check. So if node dot right is none, because we have to check for the leaf node, because maybe this is the leaf node. If this is the leaf node, then we can't insert anything into the stack further, right? So if node dot right is none and node dot left is none, and the current sum which we get, current sum equal to 0, because we are inserting the remaining sum. So target, because once we are on the 5, so we insert 17. So first we are second. Once we insert the 5, we insert the remaining sum. So when we insert 2, the remaining sum will be 0. Right? So we are checking whether the current sum is equal to 0, then we have to return true. But in this case, first we inserted 5, right? And we pop 5. For the 5, neither the left is none, neither the right is none, right? So we will insert left as well, we will insert right as well by checking. Okay, so how we are going to insert? So if node dot left is not none, if node dot left is not none, then we need to append stack dot append, and what we need to insert in a tuple root, basically node dot left. Okay, and whatever the target sum and the root value. So current target is current sum minus value, node dot left dot value. Whatever the element we insert, we like if we insert root, we are subtracting the root dot value. If we insert node dot left, we are inserting the node dot left dot value. Similarly, if node dot right is not none, if we have something on the right as well, then we will do stack dot append. So node dot right, we need to append node dot right, and we will right like insert the sum as well, node dot right dot value. If this will going to return true, otherwise we are going to return false. So let's going through this diagram as well. So first we insert 5, the remaining sum is 17. Then we will check, do we have the left hand side and do we have the right hand side? Yes, we have the left hand side, so we insert 4. So once we, because first we pop it, so this we get pop. So once we get this pop, we get 5 and we get 17. So current sum is 17 and node is 5. So we pop here, So current sum is 17 and node is 5. Then we are checking whether the node dot right is none and node dot left is none. No, neither the node dot right is none, neither the node dot left is none. So we are here, whether the node dot left is not none. Yes, node dot left is not none. Right? So if node dot left is not none, so basically the 4 is not none. So we are inserting 4 as a node. Along with that, the current sum minus value. So 17 minus 4, 13. Similarly, we are checking if node dot right is not none, then we are inserting 8, and the current sum which we popping like earlier pop 17 minus 8, 9. Now within our stack only these two element. Within our stack only these two element. Only these two. Now we need to pop. So once we pop, the last element will be pop because we are taking the list. So 8 and 9 we are going to pop. So 8, so node is 8 and the current sum is 9. Then we are checking on the left hand side, then we are checking on the right hand side. So on the left hand side, so it's 13, we are inserting 13, and the current sum is 9. So 9 minus 13 minus 4. We are checking on the right hand side, 4. So we insert 4, and 9 minus 4 is 5. Okay, so we inserted that. Now we have only these three elements. So we are checking on, we are on the, we will pop. So once we pop, so we will pop this element 4, 5. So node is 4. We will check on the left hand side. There is no element on the left hand side. There is no element on, we will check on the right hand side. Yes, there is element on the right hand side. So we are going to insert. So we insert 1, and we need to insert the sum as well. So sum is the current sum, which is 5, and the value 5 minus 1, 4. Okay, now we need to pop. So now within stack only these three elements. So we need to pop. So last element will be pop. So 1 and 4 will be pop. So 1 has no left child, no right child. Then we will check whether this sum is 0. Either 4 is 0. No, this not is 0. Okay, leave it. Then we are going to pop the another element. So 13 is going to pop. So 13 is going to pop. There is no left child, there is no right child, but whether the sum is 0, no, sum is minus 4, then we are going to leave that. Then we are going to pop 4. So when then we are going to pop 4. So we have the left child and then do we have the right child. So there is no right child, but we have the left child. So we are going to insert it, and then we are going to insert the values 13 minus 11 2. Okay. So now within the stack only one element. Now we will pop 11. So we will pop 11 as well. So we will check on the left side, we will check on the right side. It has both left and right. So we are going to insert both 7 and 2. But what is the value? So 11 minus 7, not 11 minus 7. So here the current sum is 2. So 2 minus 7 minus 5, and 2 minus 2 0. Now we need to pop. So first 2 will be pop. So the current node is 2, and current sum is 0. Then we will check whether 2 has the left hand side, or no. So 2 has the right hand side, no. But the sum is 0. Yes, the sum is 0. So we are going to return true. So we go to this path. We got this path. The same thing like we implemented here. So we are popping it. We are checking if the root is none, left is none, but the current sum is also should be 0. Then we are return true. Otherwise, we are going to again insert. So let's try to run it. So sample case has been accepted. So let's try to submit it. So our solution has been accepted. So this is little bit, you can say, not very much complicated, but as compared to the recursive solution, it is little bit uh, not straightforward. But the recursive solution is very straightforward. In the recursive solution, we don't need to do like we don't need to even care of anything. We will just say, okay, we are on the first node, check on the left hand side, check on the right hand side, and just return me true and false. Whatever the you are going to return, I will like decide my answer based upon that. That is, check on the left hand side, check on the right hand side. Whatever you are going to return, I will decide my solution based upon that. Then we are just calling again and again. Only the thing is we just need to write the base case. That is, if the like root is none, or if the left child right child is not none. That's it. So that's the end of the like solution. You can also try, and thank you.